Hello, everyone, and welcome back to NSMA Online 2021. We are now about to start a much anticipated session using drones to listen for radio frequency interference with Tom Brinkoetter. Tom's the founder of RadioSiteTest.com. He's a wireless testing expert with extensive hands-on experience running all types of electronic test equipment. He believes that drone-based measurements can help wireless site managers greatly to improve their performance of their systems and otherwise understanding what the heck is going on out there. So with that, Tom, really pleased to have you, and feel free to take it away. Thanks, Tom.
Thanks, Joe, and good morning. So I'm the owner of Radio Site Test, a little consulting company, and I would like to thank the NSMA for inviting me to present at the conference. So as Joe said, I'm retired from over 40 years in the test and measurement business as an engineer and manager for RF test products. And in my work over the years, I ran across a number of situations where I really wanted to get up in the air and find out what was going on at the antenna. And that was well before the FAA introduced the 107 drone license program. And I was happy to see that program. I went out, took the test, and I've taken it 3 times now. And it's changed over the years. So I've been experimenting, making measurements with customers now with the drones over the past 5 years. Next slide. So I want to provide an overview of the process of using a spectrum analyzer on a drone, give an idea of what can be done, and then what it takes to do it. So why would you elevate the measurements? What can you get out of it? A little bit on the FAA rules. There's a lot more out on that. I don't think we need to go through that here, but I'll touch on it a little bit. The drone hardware that I've used and partners have used, spectrum analyzers I've gone through, evaluated, and used, and then how to link the results to the ground. That's a challenge that you have to conquer one way or the other. And then I'll give some examples of some measurements that I've made. Next slide. So why elevate measurements? Well, you get to see what your antenna sees. Recently had a situation where there was interference to a public safety receiver at 150 feet, and they could not see it on the ground. They tried and couldn't do it. And I'll give more about that in a minute, but I was able to pop the drone up at the height of the antenna and find the interference and get a good bearing, and that got them going, and they hunted it down. The RF environment on the ground could be compromised either from cell phones or noise or AC, so you get up away from that. And the big advantage is eliminating multipath errors. As you know, down on the ground, the signals are going to reflect off of cars and buildings, and doing direction finding down on the ground can be quite a challenge. So next slide. So I started off with one of the smaller drones, and first thing I realized is how good the cameras are on those drones. They're just absolutely amazing. The stability, they're gimbal stabilized and software stabilized, and the images are absolutely amazing. So when I got the bigger drone for flying a bigger spectrum analyzer, I got the bigger camera, and that's a 30x zoom camera. It's stabilized, and it's, if you've ever held a pair of 10x binoculars, you realize how hard it is to hold those steady. Well, this will hold 30x rock steady, even though the drone may be wiggling a little bit from the wind. So I was very happy to see that addition to the measurements. Example on the right is a cell site, and I'm about 100 yards away. Zoom in, you can see, I can read the label off of that from 100 yards away. Next slide. So in August 2016, the FAA introduced the 107 program for licensing drone pilots. And before that, you needed a full pilot's license to do this kind of work. And the license has changed now over the past 6 years. You have to take the test every 2 years. And to their credit, the FAA is trying to keep up with this rapidly changing environment. The key things, if you're going to do anything for revenue or value, you have to have the 107 license, which is a pilot's exam that you take just like any other pilot would at a test center. The pilot is totally in control of what happens, so he loses his license if he messes up. You can't fly over people. The drone is limited to 55 pounds, which is a pretty large drone. 3-mile visibility, that's normal airspace. You can only fly at night with a waiver and then approved airspace. And that has changed a lot. In the beginning, the rules were you couldn't fly closer than 5 miles to an airport. And it turns out that in most cities, the hospitals have heliports for helicopters, and you'll find little circles all over the city, and there's nothing left. You can't really fly your drone in any city because there's so many little hospitals and airports. So that kept all the real estate agents from taking pictures of houses and stuff. But in those days, your drone would just tell you you're within 5 miles, but it would still let you fly. And then as you updated your firmware, the drone would just not fly. And now with this low altitude authorization and notification program, you go to a website and if you request approval, if granted, then you get instant approval. So that's a great advancement, and that allows you to fly relatively close to an airport. Of course, they're not going to let you fly right in the landing area, but you can get closer than 5 miles now with this LA&C program. Next slide. So obviously, you must know there's a huge variety of drones. There's a new little less than a half-pound drone from DJI that has a good camera on it, which is amazing, something that light, up to the bigger ones, the Matrice 600 that I fly. And what's made all this possible is the inertial measurement unit that these drones have. I don't know if you've had a drone before, but the early drones didn't have very good control. And the first thing you do is pop it in the air and crash into a wall, or it would go down very quickly. So these IMUs have all manner of sensors on them, from laser to sonar to altimeter, et cetera, to provide stable flight. So now they really are very easy to fly. So that's what's made these possible. So there are a lot of consumer drones that you might consider for mounting a spectrum analyzer on. And you need to be careful about that, because the consumer drones, there won't be any specifications from the manufacturers on payload. So if you put a 1 pound payload or 2 pound payload on a DJI Phantom, you're taking a heck of a risk, because if it goes down, you won't be able to explain what you did. There are drones with payload. My Matrice has a 14-pound payload. Most of these drones have a 30-minute flight time, which is good enough. You can easily, for what I do, you can easily drop it down, put a new set of batteries in, and pop back up. So I don't think that's a big limitation. Now, you see the Matrice 600 on the right is a drone that was used by Hollywood for movie making. You see the landing gear moves up out of the way, so the camera has a 360-degree view. And it's incredibly stable in flight. It has redundant IMUs and GPS receivers to work in GPS deprived environments. So it's one of the most stable drones you can put in the air. DJI also has a Matrice 210, which is more of a public safety oriented. It's a little bit smaller. Would be a good one for mounting a spectrum analyzer on. And of course, the issue is that DJI is a Chinese company, and there's issues of taking pictures of GPS location with something that the data might go back to China. Next slide. So the American manufacturers have popped up to offer a solution for that. UAV America out of New Hampshire has drones comparable to the Matrice 600. BFD Systems also has a whole series of drones that you could use to put a good spectrum analyzer on. The problem for me, I'm an individual consultant, so the starting price for these US drones are $25,000. That's without camera, without any accessories, versus the $6,000 for the Matrice. So there's an issue there of being able to afford those American-made drones just for that label. Next slide. So, of course, you're going to have to mount the spectrum analyzer on there somehow. The FAA does not have staff to be reviewing your modifications to your aircraft, so they put it on the pilot to be totally responsible for any outcome. So what I've done is modify the landing gear on the Matrice. As I said, it swings up for camera work for Hollywood stuff. I don't do that kind of work. I always have the antenna that I'm using aligned with the camera, so I don't need that gear to go up. So I added another support in there and made a platform for the spectrum analyzer. And I have 3 different kits, analyzer and PC to run the analyzer that fit on there. And of course, if you're doing any kind of work with a spectrum analyzer, you got to be sure that you don't overload it. So you'll probably end up with some filters on there, and you'll of course have to have an antenna. So that's what you have to be prepared for to do this kind of work. Next slide. So the spectrum analyzers, I'm of course always hunting for something small and light. I've tried many of the little USB sticks, the software-defined radio sticks that you can get for $20 all the way up to a couple $100 for a USB spectrum analyzer. And frankly, they just don't have the amplitude accuracy or the performance that I think is necessary to do this kind of work. So I'm looking for one in the future. Hopefully one comes out, but at the moment, I'm using the analyzers from the classic test equipment vendors. I have one of the Enritsu. It's USB powered, so I use a tablet PC to run it, and so I fly both the tablet PC and the analyzer together. There's models to 110 gigahertz, so it certainly has a range to cover most needs. It's a unusual block diagram, so it's good for CW signals, but maybe not as good for intermittent kinds of signals. But it does have the frequency coverage. SAF is a point-to-point microwave company, and they make a little handheld analyzer in waveguide bands up to 40 gigahertz to support their installers. And I've had that and evaluated that. You can't fly it, but you add a PC to it to link the stuff down to the ground. So those are 2 good solutions for coverage up into the millimeter wave band. Next slide. For work below 2 gigahertz, I like the Signal Hound. It doesn't require quite as powerful a PC, and the challenge there is for both finding a tablet that's powerful enough. The Enritsu and the Tektronix require an i7 with 64 megabits, 64 bits processor. So it can be intermittent, it can be tricky to keep that running connected to the PC. The Signal Hound is a little easier. It's good. Relatively good amplitude performance. It does have a little narrow real-time capability. So for below 2 gigahertz, that's my preference. Tektronix has had a USB-powered analyzer for some time, 6.2 gigahertz coverage. It does have real-time performance to 40 megahertz. So we'll talk about that in a second. Next slide, Marianne. Yeah. So the issue with choosing an analyzer, of course, making sure you have the frequency range you need. The sensitivity, you'll want to make sure it's pretty close to what you're using in your radios that you're testing. Hopefully you can get it as sensitive as the equipment that you're trying to protect. The dynamic range, if you have large signals, you want to look at small signals for interference in the presence of large signals. The dynamic range spec is important. Spurious, a lot of these analyzers, especially the real-time ones, if there's a large signal coming in the front end, they'll generate spurious phantom signals that are not real. And you're going to want to be careful about that, or you're going to be chasing your tail. And then is it real-time or just swept? The older block diagram of just swept. Next slide. So the real-time processing is an emerging technology that adds a lot of horsepower to the IF processing that after you digitize the IF. And it provides an incredibly fast update rate. And to provide a view of all that data, then they created a new kind of display called a probability density display. And there you're looking at, this is a display of maybe a few seconds of history of the Wi-Fi spectrum. And the blue signal is a very rare event. So that color then indicates how often the signal occurs. The reddish orange signal is the noise level, and it's very common. So it's there all the time. So this allows you to see rare events in the presence of all the other events, whereas a swept analyzer is going to be sweeping through, and an event can happen while it's looking on another part of the spectrum. So you only may get a piece of that. This, by the way, is Wi-Fi spectrum, and Wi-Fi is time division duplex. So the transmitters are going to only be on for bursts, and swept analyzers have a difficult time with these kinds of signals. So I'm looking forward to some emerging, smaller, lightweight analyzers that have this capability. So fingers crossed there. Next slide. So of course, in any interference hunting or signal analysis, you're going to need a good antenna. You're going to need an antenna that you know. And I had a heck of a time finding appropriate antennas to fly on a drone. Most of the horns that I can get my hands on are heavy, many pounds, and that then prevents me from using them. So I've ended up having to fold copper to make lightweight horn antennas. On below 2 gigahertz, I'm having to make my own Yankees that are lightweight. Most of the antennas you find are for outdoor rugged environments, and they're pounds heavy antennas, and you just can't fly that kind of thing. So I'm making my own. The antenna on the right is a 6-element 700 megahertz antenna that has 10 dB of gain, and was successfully used to do a interference hunt in Northern California. Next slide. So I'll go through the flight logistics. If I get a project to do, the first thing I need to be sure of is a landowner going to allow me to fly a drone there? You can't fly a drone in state parks or federal parks. So there's now, with all the stupid things drone operators have done, the people are clamping down on them. So there's a good possibility that the landowner wouldn't allow drones to be flown, and that makes the project not go. The second is airspace. And now with this LAANC program, I'll do a trial test to see if the FAA would approve flying there. And it can be tricky, but if you're careful, you can work through the gates there and get the airspace done. Then I'll do a horizon study. That is, I need to know what the horizon is going to look like when I'm up in the air looking through the camera. So I want to make sure I can get bearings down to a few degrees. Unfortunately, the compass headings coming off of the drone are not very good. So I'm having to use horizon to get to accurate headings. Weather, of course, you got to make sure you got the 3-mile visibility. So there's a lot of restrictions, as any plane would have with weather. And then people management. This is a real problem. You can't legally fly over people. And unfortunately, these drones are attractive nuisance. I try to cordon off the area. I've got tape, barriers, and I'll be darned if people don't lift the darn barriers up and come over and want to talk to you while you're flying. And you just can't let that happen, both legally and of course, you're incredibly busy when you're flying, watching the spectrum analyzer, making sure everything goes right. You can't talk to people, so you've got to somehow deal with that people problem. That's a real barrier. So my flights, because I'm just elevating a spectrum analyzer up, slowly rotating, looking at the horizon, taking pictures, looking at the spectrum, are straight up, rotate around slowly, come back down. So there's very little loading on the aircraft. I don't do the 100-mile-per-hour chasing of cars like in Hollywood. So, I think all the hardware has been stable, and I haven't had any issues with that, pieces flying off as I'm trying to make measurements. The issue, though, is time aligning the spectrum analyzer data with the video data. All the images on the drone are time stamped to GPS. That's good. But the spectrum analyzer takes some work, so you've got to figure out a way to time align the spectrum data and the GPS and the image data. So that's part of the project. Next slide. So I end up having to do a post-study. When I come back down, I begin aligning the timestamps on the images with the spectrum data. And then I'll use the Google Earth images I have of the horizon to get accurate bearings. And it turns out that that's very important. Unfortunately, the drones that I have don't give me a good bearing. They show you the general direction, but they don't give you a bearing as you would need to do direction finding. So there's a fair bit of work after you land to be able to say that signal is coming from exactly that direction. Often, though, you can use that camera to see what's going on the other end. And I think that's the next slide. Oh, and getting good measurements to the ground. So in the beginning, I didn't have a good way to see the signals on the ground. So I used the PC in the air with the analyzer and just stored the data locally. So I set it off, scanning and storing traces, put the bird up in the air, rotate it around, come back down, and then look at the results. So that's one way, the simplest way. Next, I moved to using Wi-Fi. Since I have a PC in the air, it's got a Wi-Fi link on it. I have another PC on the ground with Wi-Fi, and I link them together using Microsoft Remote Desktop. And that's fine. Wi-Fi is a little sensitive. If I have to go up above 300-400 feet, that Wi-Fi link gets a little unstable. And the advantage of that, though, is I can actually control the drone, control the spectrum analyzer. I can make adjustments. Although I think while you're flying, if you're trying to run a spectrum analyzer too, unless you have a second person, is tricky. So generally, I set the analyzer up as needed on the ground, resolution, bandwidth, all the filtering, detection, et cetera, and then put it back up in the air. Another way that I've brought the data down is the drone industry has extra cameras you can add to the bigger drones and an HDMI radio link down to the ground to a monitor. And I've used that coming out of the PC. I'll take the HDMI out of the PC and then watch the spectrum analyzer on the ground that way. You can't control the analyzer, but you can see the screen, and that's a robust link that'll work further higher altitudes than the Wi-Fi. The holy grail here is embedding the RF measurements from the spectrum analyzer into the drone control link. And DJI offers a software development kit. But as I'm going through a variety of analyzers, I just haven't had the money. It's going to take a couple months of a software engineer to get that working, and I haven't had the money to make that investment. But it's available, so you can get your spectrum analyzer data on the same wireless link as the control of the drone. Next slide. So here's an example of an interference project in Northern California. I worked with CSI telecommunications engineers out of San Francisco. And the FCC was there as well. They've been plagued with this interference now for a few months, and we're trying to figure out where it was coming from. Their receive antenna was at 150 feet, P25 system at 700 megahertz, and they could not see the signal on the ground, even with high gain Yagi antennas. So using the matrice and the signal hound, I popped up just above the antenna that they were using. First, I looked at the signal on the ground coming down the monitor link on the P25 system, so I knew what it looked like and set up the analyzer on the ground, and then hooked up my 6-element Yagi and put it on the bird and flew it up to the antenna. And I could see it and very slowly rotate the drone. I peeked on it and gave them a bearing. And they were off to the races then, where they got that bearing and moved down in that direction, and they were able to. It was a nursing home with a booster amplifier that was oscillating, classic interference for public safety. So very good success story for drone interference hunting. Next slide. In this example, another a city public safety had poor coverage at the police station just 5 miles away. So it's a P25 system again, separate transmit and receive antennas. Those are the long sticks on the right of that photograph. One on the very top, the receive was on the top, the transmit was on the side. And we verified that the antennas were good in the match. They were worried that the antennas were either mislabeled or damaged, maybe hit by lightning, and they were sending the signal up in the air rather than horizontally after the police station. So I measured the signal strength with the drone moving up and down in the direction of the police station. wasn't able to fly around the tower. I didn't have landowner permission to do that. I only had it in one direction. And the plots on the lower right are signal strength versus vertical position. The notches are intentionally put there as markers for where I am. The first marker on the left, notch on the left, is where I'm level with the antenna. And it turned out the antennas didn't have up tilt as we were worried. They were working properly, but we did notice that there was a huge difference between the receive antenna and the transmit antenna, 5 dB difference. And likely that's because the antenna was mounted to the side of the tower, and for whatever reason, the pattern was distorted by the tower and pushing the signal off to the left in that picture rather than out towards the front of the picture, towards the police station. So since their system was outvoted, they had many other receivers. We just switched transmit and receive, giving 5 dB more signal to the transmit, and that solved the problem and was a nice low-cost solution for them. So good use for antenna pattern measurement. And next slide. Okay, so Mariana is going to show a couple of examples. This is what the camera can do. These are both point-to-point microwave systems. And in both cases, we're trying to weave the location of one of the ends of the point-to-point system in between some trees. They didn't have permission to cut down the trees, so they're trying to position the tower so they can get 10 years of point-to-point. And Marianne, can you show one of the videos? Yeah. Okay. Nope. So again, this point-to-point system, I think, is about a 5-mile shot, and they're trying to be sure they can put a receiver on this tower. So you can see how tricky that shot's going to be. So we did have line of sight, but just barely through the trees. And then the second one. This one's a little further. I was surprised we could see that far. This is a cell site they were going to put in, a virgin site, and they're going to get their data off of a ski resort 10 miles away. And I'll be darned, it's a little hard to see, but it's there. So we knew we had line of sight. Look at the tree right there. We just barely skimmed that tree. So that site was going to work for a few years anyway. And next slide then, Mariana. We're almost to the end. Okay. We can go to the last slide, I think it is. Okay, so to summarize, a drone on a spectrum analyzer can give you line of sight to an RF source. Often you can just see what it is and go deal with it with the visual. The stabilized zoom camera is absolutely amazing, so that is an aid. And I think these elevated spectrum measurements can help locate interference in those very tricky situations. So with that, I again, thank you for allowing me to present and open it up for questions.
Thank you so much, Tom, and thanks for including those fun videos as well. We have a couple of questions already in the chat, but I also wanted to encourage y'all to use your little raise hand button. That's a way that we can bring you on stage. You don't have to have your camera on if you don't want, but you can at least be talking to the speaker. It's great to hear more voices and not just ours. And I know as a speaker, it's fun to have some interaction, especially now that we're virtual. So Joe, if you want to start with a couple of questions that are in the chat, and hopefully we have some brave souls in the audience who will raise their hand, and I can get them on stage with Tom as well.
Thanks, Mariana and Tom. And yes, Tom, so the first question is, do you ever have problems with the communications link to the drone being overwhelmed by RF coming off radio transmitters on the towers themselves?
I have, and let me tell you, that's a scary moment. And, you know, really, for most of the measurements, I think you want to be in far field. You don't want to be up, right? I can't think of a measurement where you want to be up in the near field. So I learned the hard way. You want to stay in the far field, both for that reason. And these drones, the drone I have operates in the Wi-Fi band, ISM band at 2.4. And I flew up next, pretty close to a 2 gigahertz cell site. And fortunately, the drone just locked up. It didn't fly off into space. It just froze, and the controls didn't work. And with some a little bit of tense moments, I was able to get control back and land the drone safely. But they're pretty robust. These things know about RF. They're used in this environment, and they're pretty darn robust. But if you fly right up against a cell tower or right up against a kilowatt, you can take them out. So you've got to pay attention to that. But I think you want to be in the far field anyway.
Yeah, that makes sense. And with
oh, sorry, Joe. We have Joseph Miller who is willing to come up on stage. So we're gonna bring him in. Joseph, you should be able to have your camera if you would like, but definitely your audio on, so you can go ahead and ask Tom your question.
Hey Tom, how you doing?
Hey Joe.
Just seeing the pictures and some of the things that you were able to put together to fly up and do your analysis. I mean, that's pretty interesting. Just out of curiosity, I know obviously weight is a huge factor, even though, some of them can carry pounds up to 14-pound loads and whatnot. Yeah. How limited is your flight time based on the weight of, I guess your best, conglomeration you've put together, just out of curiosity?
Well, they're stated at about 30-minute flight time. I don't push that. I get really, it starts to make a lot of noise. The bird's telling you that your battery's getting low. And I've got a lot of money in the air, and I generally bring it down in 20 minutes. It wouldn't be hard to have an extra set of batteries. It only takes 5-10 seconds to switch batteries. So in that case, I would bring it back down, switch batteries, and come back up and do what I'm doing. As I say, I fly straight up and just rotate the drone. I don't do any adventurous flying. So I'm not having to bring the drone back from far away to deal with that. So it's 30 minutes. The weight has a little bit of an effect, but not a big. My drone, I don't think it has much. I only am running about 3 or 4 pounds, depending on what I put on there. So I'm way under that drone. I have never pushed the 14-pound payload capability. I don't have the courage to do that.
Well, I think that's smart, staying right there, and then you can just come straight down. Just from experience using, handheld items, like whether that's the PR200 or a V-Rod or whatever being on the ground, yeah. I'm constantly, explaining to military leaders like, hey, this is what I can get from here, and I can give you a, sort of a quick analysis. But God, if I was 100 feet in the air, this would look a lot different. So I think your use of the drones is extremely valuable, and I think that's something that people should take part in more often.
Yep, it's been some work, but it does some things that you can't do otherwise. You're right.
Thank you very much.
Thank you.
Thanks for hopping up on stage, Joe. I'll send you back to your seat now.
Thanks, Joseph Miller. Thanks, Mariana. There's a few other questions here. One is, on the people management issue, does this mean you can't do interference hunting in dense urban areas, or are you precise enough where you can just put a 10, foot diameter circle and go straight up and straight down, and you're technically complying, or how does that work?
You are. If you get flight approval, if you get airspace approval, then what you're going to have to do is cordon off the area to keep people. I think it's a 45-degree angle. So if you're 100 feet in the air, it's a 100-foot radius. So that would comply. So if you can get airspace approval and you can get enough people on the ground to drive the looky-loos away, then you could do that.
Yeah. So you basically have a celebrity concert. You have security people in vests or whatever around you.
It's crazy. And I've put barriers out, and people walk under the barriers and walk over to you and just go, wow, what did you think that tape was for?
So it sounds like you're gonna, especially in urban area, you need a lot of signage or live security personnel,
right, because you're really busy when you're flying. If you're looking at the analyzer, hopefully you have a second person doing the spectrum analyzer work, but you're really busy. You can't talk to people while it's happening.
Yeah, we have another live person, I think, and then we have some other chat questions, but let's go with a live person. Mariana's running that.
James Wolfson, we're bringing you on now.
Okay. Oh, my picture. There we go. There I am.
Hey, James.
Mr. Brinkoetter, yeah, I've done a lot of spectrum measurement interference things in my career, haven't lately, but it's tricky at best when you're sitting on the ground with a spectrum analyzer and aiming an antenna and all that to determine the bearings. That's kind of unique what you're doing there. My question was really, how long does it take to get this clearance from the FAA? I mean, you have, is it 10 days or 2 weeks or a year or a few hours?
The LAANC program is almost instantaneous.
Okay.
So if you're going to get approval, you're going to get it right away, or you get denial right away, one way or the other. But you'll know right away. So that's a wonderful piece of work done by the FAA.
Okay. That was my question.
Great. Thanks, Jim. Jim's a longstanding board member, as is his wife, Vivian. They're always asking good questions. And kind of related to that, one of the other questions it came up that was, does that mean it's instantaneous to get a license, or it's instantaneous to get the flight approval? How long does it take to get a license, and how long is the license term?
License is 2 years. You have to take it at a normal FAA testing center, and you'll know within a few weeks once you've passed the test. So that is a normal pilot licensing sequence. The approval to fly for doing commercial work like this is what the new AANC program is instantaneous. As I said, you go to a website and you're going to know right away whether you're good or bad. And they, if you're pushing the limit, you can't justify it, they'll deny it right away, or if you're good to go, they'll approve it right away.
That's awesome. In terms of it taking a few weeks to get the core license in the first place, does that include you starting from ground zero with your studying, or did you study for a month or a year and then a few weeks?
These tests are hard, so it's a good month of hard study for me to pass the test. Maybe that's my problem, but it's a hard test, no question about it. It's a pilot's test, and there's there's airspace, there's weather, restricted airspace consideration. There's a lot to learn. So it's not a casual test. It's a serious test. It's almost the normal private pilot's test. A lot of the same stuff. Wow. Except on top of that are battery management, because these batteries are lithium ion, and you got to be careful with them. And there's a lot of battery questions, a lot of drone maintenance questions. So it's a pilot's test plus appropriate drone stuff. Wow. It's hard. I'm not going to kid you. It's a hard test to pass.
Yeah. Well, hopefully, you don't want people with 14-pound payloads just zooming around with.
That's exactly. You don't. Well, these are flying lawnmowers, so you got to be careful with them.
Yeah. I hear you. When we were kids, you'd have these Bazooka Joe bubblegum things, and you get a certificate with your cartoon. But I think this is a bit more rigorous. Is there a fee?
It's minor. It's not a lot. Maybe $200, I think, to take the test. Yeah, okay. $200, I think.
Not so bad. And then another question that come up had to do with you were very inventive making your own antennas. You found there's a demand and there's no supply for that demand, so you're making your own supply.
Right.
So getting into the antenna world, and we have a lot of antenna experts here. So one of the obvious questions that came up were, there's two types of, or maybe more than two types, but at least two types of needs. One is you just want to identify where signal's coming from, or can you connect? So there's that layer. And then there's people who are getting into more Doppler bends type of precision antenna work. Are you going through any sort of a calibration, or where are you trying to do some exceedingly precise measurements for a more calibrated world, or are you really just trying to signal identify and signal confirm, or both?
Well, for DFing, 10 dB of gain with the Yagi, it's got a fairly narrow, probably a 10-degree nose on the antenna, so you can peak within 10 degrees. And I think and then you're looking through the camera. If you can see something at the other end, then you've got some confidence. So I think 10 degrees of the antennas I can get my hands on are as good as you can get. You've got to be careful how big an antenna you fly. You don't want to have wind load. If it's breezy or not, you don't want to have the wind. And what will happen is the drone will cock, if you will. It will adjust itself into the wind, so it arcs the antenna a little bit, so you won't have vertical or horizontal polarization perfectly if there's any wind at all. Even
Tom, I think Tom's screen froze. We'll give it a minute, see if he comes back. Oh, we lost the connection. While we're waiting for Tom's signal to come back, I do know we have a question from David Meyer, and I'll just repeat the question to the audience. What has been the most challenging measurement you've done with a drone? So we'll see if we can get that question asked of Tom Brinkoetter. Here comes Mariana.
And also, while we hopefully get Tom back, I wanted to just kind of encourage everyone to use our lounge tables during our launch session. You can leave the table, join new ones, start new tables. It's really a way to really connect with other people. Feel free to unmute yourself, obviously, and put on your camera if you would like. But we will have that whole break as a time to network as well. The lounge will be open, so you can quite literally eat your lunch with other people. So just wanted to put that on everyone's radar as well. Joe, I think, do you want to wait for Tom, give him a couple more minutes to maybe join us, or should we go ahead and let people leave for lunch? We can always start a little bit early if he comes back.
Yeah, well, how about this? Why don't we just sort of give it a minute and let people just chill out and to see if there's any, maybe offline you can try to reach out to Tom on his mobile and see if he's aware that he lost signal. He might be talking to his screen and not the rest of the world. Here he comes.
There we go.
Hey, Tom.
Am I back?
There we go. Yeah, not sure what happened there, but glad to have you back. So another question we got from David Meyer, one of our board members, what has been the most challenging measurement you've done with a drone?
Oh, well, I think these where the signal is weak. So I've had requests to do work at VHF, and it's a noise floor measurement. So I'm right down near the limit of the spectrum analyzer, and it turns out the PC itself is generating enough RF hash that it raises the noise floor. So I'm having a heck of a time at VHF frequencies getting a noise floor down where the actual receivers would be. So I haven't conquered that yet. I'm trying to relocate the antennas, and of course you have to shield the PC and the USB cables, and so getting the noise floor down at VHF frequencies has been the most challenging.
Okay. How many, there's such a unending set of variables in terms of the types of networks you could probably be helping folks measure for construction or for compliance or for trying to understand third-party interference. But looking at all those variables, roughly how many, let's say, links in a multi-point fixed wireless network could you measure in a day? What's like, and do you have multiple crews, or how does it all come together?
So I'm a single man guy, this tiny little company. I think you're looking at 2 a day, because you've got to analyze the results when you depends on how tricky the work is. Sites that are like 10 miles away, it's actually very difficult to pick out of the camera. The camera's powerful, but once you zoom in, there's a lot out there in the field of view, and it's really hard to pick a antenna site out at 5 miles or even 3 or 4 miles. So you're going to be looking through the camera for a good period of time to be sure you know what you're looking at. And I think the same thing is true of the spectrum data.
Yeah.
By the way, another fun application for this was hunting for wolves with radio collars on them up in Montana.
Oh, wow. Is that successful?
Yeah. And of course, they have a 200 megahertz 1 pulse per second little signal and tricky to find, and of course you're in the trees, and no, that's another application for this.
Well, that dovetails with a program we have tomorrow afternoon about how in terms of RF and green earth type of programs. There's a lot of programs where folks are trying to build cleaner air, water, restoration of forests, and of course with restoration you get more wildlife, and clearly you're using this new technology to help track that wildlife, and that's
Right.
that totally dovetails with some other programs where spectrum managers can start working in other areas they hadn't really thought they were going to work on. They thought they might always have to only work on hard scale networks, and it's there's a whole another world out there now that everyone's using all kinds of wireless devices.
Right.
So really onto something. There's a set of questions from Andrew Clegg, another one of our board members and another past president. He asks, one, what are the limitations if you don't have a Part 107 license, i.e., what can you do as a hobbyist drone flyer? In terms of RF measurements specifically is what he's asking.
Well, okay, so first of all, the LAANC airspace approval is only for 107. So if you're a hobbyist, you won't be able to use that website. So you're going to have to stay away from most of the airports. So you'll now have to be out away from the cities. I guess you could fly a spectrum analyzer just for fun. There's nothing that would prevent you from doing that. If you're doing it for any commercial purposes, though, you really want to have a 107. Right? If something goes wrong, and you're going to get a lot of questions, you're going to want to be able to explain them.
Okay, so your take is that because you look at your audience. I mean, a lot of us are going to go get our drones and start,
Oh my God!
How far does my Wi-Fi signal in my backyard go, or who knows what we're doing? But the checking out our bird feeder or whatever, and hovering around it. But in terms of if you're taking a fee for service and you smash through your neighbor's plate glass window or whatever, then you're gonna have the FAA in your grill, and
Yes.
they're gonna be like, and then your point is, well, if you had gone through a certified licensed pilot program and you were registered as this is a approved flight path, you're less likely to get in a lot of hot water. Is that
Right.
your point?
That's right. That's exactly right. And the smaller drones can be taken away by the wind. So where things go wrong is you put it up in the air and the wind takes it over. And there was a case where a guy was illegally flying it in Las Vegas, and the darn thing got away from him and landed at the airport. Well, of course, the drone has all of his ID on the memory stick. They hunted him down. He got a $20,000 fine. So it's not a casual. You take this seriously. The FAA knows what they're doing, and I guess if you're going to do much of this, go take the test. I highly recommend you just go through that extra effort.
Yeah, $20,000 fine. That's
Yeah.
get yourself a high-end USA drone that way. Yeah. Looks like we have another question from James Wolfson.
Yeah, I got another quick question. Have you ever used LNAs, low noise amplifiers, to help with your signal gathering? I mean,
I have.
Okay.
I have, yeah. Of course, with a spectrum analyzer, you've got to be careful. You want to filter in front of that, or you're going to have all manner of spurious signals. Of course, yeah. No, that's a good addition to the analyzer if done carefully, because of the spurious issues you're going to have.
Right. I got you. Okay. Just curious.
Yeah, but there's some good ones out there. So Mini Circuits makes relatively inexpensive 2 dB noise figure LNAs that power from 5 volts. You usually have 5 volts on the bird. So, by the way, the bird battery you can pull off the 16 volts off the bird and power your electronics.
Wow, that's a good hunk of energy. On the China-made issue, obviously, with a lot of networks, there's going to be the whole Huawei issue and everything. There's going to be a lot of requirements to just totally avoid it. So with the U.S. made drones and the versus Chinese-made drones, assuming that also was going to apply to U.S.-made spectrum analyzers, or
I haven't run across that. I've had a couple of tiny, relatively small China-made spectrum analyzers, but I have, frankly, there was no manual for them. I was never able to get them to work right. They'll be making spectrum analyzers. I don't know how people will deal with that. I don't think it's the same thing. Of course, the drone is capturing GPS and imaging,
right?
and there's worry that could find its way back. Although these files are enormous, you're going to know if you're sending a gigabyte file somewhere. So I don't detect a DJI sucking gigabyte files off of my memory sticks. So
Yeah,
but the worry's there.
yeah. And some analyzers have their own GPS attachments to them. They're on their own.
The handheld, the Brinkoetter handheld ones, they're a little heavy. I could probably fly it, but I can't put that much money in the air. It's pushing the limit of the bird, and it's a lot of money. So I haven't had the courage to fly up a full portable spectrum analyzer.
Do you have any experience or heard any stories with, what are the more expensive crashes beyond the ones with fines? But
well, yeah. So around the cell sites, I've heard many stories of people wanting to show off how good their drone is and immediately crashing it. I've witnessed one. We were flying, in fact, I think it was a UAV America, and the GPS was denied because the cell site was in trees. So the GPS was denied, and we're not quite sure what happened, but it went kind of crazy at the bottom and just tore some blades off. It didn't explode or anything, but all it takes is losing GPS, and these things are really hard to control. Yeah. And it's not hard to be in an environment. We were in trees. The cell site was in a hole in the trees, and as you started to land, the GPS was denied, and the drone was hard to handle. So, yeah.
It can go downhills quick if you don't know.
Yeah, and these spinning blades, I say, it's a flying lawnmower, so you get the same effect. It's the same as you would expect from a flying lawnmower.
Yeah, I hear you. That's words for caution. So professional grade operators. If you're a company or you're worried about liability, that's and I assume you have some sort of insurance or bonding or something you present.
Yes.
All right. Well, that makes a lot of sense. Well, I don't know if we have any other questions or any other aspects you wanted to touch on, Tom, or I don't see any more questions.
Thank you, Joe. Appreciate the opportunity to talk here.
We're pleased to have you. This is very innovative, and we'd love to hear more as this technology develops. And thanks for coming aboard. All this is recorded for our members, so I'm sure people will circle back to this.
I encourage the test equipment vendors to think of us drone people and get some real-time analyzers that are small and light.
Yeah, there you go. All right, equipment people, you've heard it from the man himself. All right, thanks so much, Tom. Pleased to have you. And for everyone else, we're going to take a break until 1 p.m. We'll be back with Satellite Mega Constellations panel with John Janka, Chief Officer of Global Government Affairs at Viasat, Trey Hanbury, partner, Hogan Lovells, and then after that, we'll have Politics of Spectrum Sharing with Mitchell Lazarus, former consul with FWCC, and a former retired partner of Fletcher Hilton Hildreth. And then we'll have a break, and at 2:45 p.m. we'll have New Ideas in Spectrum with Thomas Kidd, a real exciting program. A lot of very interesting new ideas. He's Director of Strategic Spectrum Policy at the Department of Navy. And then we'll have an RTA Spectrum Management certification going back to the heart of what we do. A lot of spectrum management certification program information from their chair, Tom Fagan. So that's the preview for this afternoon's program, and have a great lunch, and we'll see you at noon Eastern Time. Thanks so much.